So this question says that we have a piece of lead fastened to the top of a large piece of styrofoam. So let me not move my page, but let's draw the picture. So I have a piece of lead attached to a large bit of styrofoam. And when we have it in this condition, the water line is right at the top of the styrofoam. We want to know what happens if we turn the styrofoam upside down, where we now suspend it beneath. So I have the second case is where I still have the same amount, and I want to know where the water line is on this. Did this thing move up or down based off of us flipping it over? Well, to do this, I'm going to draw a free body diagram of the first object. I know that the upward buoyancy force is equal to the density of the fluid, the submerged volume of the object, times gravity. And I know that I have a downward weight force. And my downward weight force is m1 plus m2. I'm going to consider this object to be one object. And it has a weight force of m1 plus m2g. M2 and M1. The volume that's submerged is actually only this volume. It's the volume of the styrofoam. So now if I flip the thing over and draw the free body diagram again, I still have the same M1 plus M2, right? There's a weight force pulling down. This thing still has gravity pulling down. I still have the same upward buoyancy force because this thing is floating. Density of the fluid, the volume of the submerged object, and this is going to be a primed value. So it's a prime value because it might have changed our volume, or our submerged volume, and gravity. Well, I look at this picture and I look and I say, if it's at the very top, the water line is still flush with the top surface of the styrofoam, well, then I have the full volume of the styrofoam plus the volume of the object, of the lead ball. But since we have the same weight force, we have the same buoyancy force, we have to have the same submerged volume. So I can't submerge all of the styrofoam because I'm now submerging the lead as well. And that lead has some volume to it. So the water line can't be flush. Well, I know that if I were to submerge all of it, it would have a very large submerged volume. It'd actually be a larger volume than this, which means our upward force would be pushing on this higher than the weight force, which means this thing can't actually sink. Going to sink down in the liquid a little bit, but as soon as we submerge enough volume, then we're going to have the same, where we equal our weight force, then we're going to be in equilibrium. We won't fall anymore. We won't rise or fall. So the water line is below the top surface of the styrofoam. So this is the right answer. It doesn't, our submerged volume will be the same volume as before, but it won't be all the way up to the top of the styrofoam. It's kind of a cool little problem. It's a conceptual problem. It requires us to think and figure out what changes, what doesn't change. And these flipping something over, there's another question where you drop an anchor over the side. These problems can have some difficulty with them. You got to really think about what changed and what didn't change.